Okay, today we're going to be doing our last day of section 4.6, which is using standard form and finding our x and y intercepts. So first we have to remember what x and y intercepts are, and they're basically where they intersect both the x and the y axis. So our x-intercept for our first graph would be this point right here where it intersects the x-axis. So that would be the point 4, 0. And please make sure that you write all of your intercepts today as points. Do not just write the number 4, write it as a point 4, 0. Now let's do the y-intercept. Looks like our y-intercept is right here, and that is going to be the point 0, 3. We go left and right 0, up 3. So again, make sure you're writing them as points. Let's try number 2. X-intercept is where it touches the x-axis. So it's going to intersect the x-axis at 2, so that would be the point 2, 0. And then when we want to find our y-intercept, that's going to be the point 0, negative 4. One thing to notice about both of these intercepts, for the x-intercepts, the second number was always 0, right? Because you're going left and right however much, and then you go up and down 0. So your second number for your coordinate for the x-intercept will always be 0. And for the y-intercept, the first coordinate is 0. Or in other words, the x value is 0. Because you go left and right 0, and then you go up and down however much. Oh, and I'm sorry, this second one, shouldn't that be a negative 4? My bad. 0, negative 4 there for your y-intercept, because it intersects at that negative 4. Okay, let's try our next example. So now we want to find the x and y intercepts when given an equation and not a graph. So the way that we do that, to find the x-intercept, we're going to plug in 0 for y. And to find the y-intercept, you plug in 0 for x. So you basically just plug in 0 for the opposite letter of the intercept you're trying to find, which should make sense because when we did our x-intercepts, we had some kind of a number here, and then the second one was always 0, right? That y value was always 0. So it would make sense that we plug in 0 for y. Same with our y-intercepts. When we found those intercepts, the x value, that first number, was always 0, and then whatever the y value was. So it makes sense to plug in 0 for the x. So let's go ahead and find our intercepts here. X-intercept, we're going to plug in 0 for the y value. So we would have 2x plus 7 times 0 is equal to 28. Oops. Well, 7 times 0 basically just goes away, right, because it's 0. So we're left with 2x is equal to 28. So x is equal to 14. So my x-intercept, we got 14 for x, and we had plugged in 0 for y, so my y value is 0. Now let's do the y-intercept. This time we're going to plug in 0 for the x. So we have 2 times 0 plus 7y is equal to 28. So 2 times 0 goes away because 2 times 0 is 0. So we're left with 7y is equal to 28. So y equals 4. So my y-intercept is 0, 4. We plugged in 0 for the x value, and we got 4 for our y value. Now, if you notice this little note here, it says to use the cover-up method. So I'll solve this next problem using the cover-up method. And basically what that means is you cover up the variable that you are not finding the intercept for. So for example, if I want to find the x-intercept, I'm going to just cover up the y, and then I'm going to solve my equation. So if I had the equation negative 3x equals negative 15, I would get x equals 5. So my x-intercept is 5, 0. And the reason that cover-up method works is because remember how when we plugged in 0 for y, that term just went away anyways? It's just kind of a shorter way of doing the plugging in 0 for y. So let's go ahead and do the y-intercept. We know the x value is going to be 0 because we're plugging in 0 for x. And we'll use the cover-up method where we just cover up the x value. So we have a positive 5y equals negative 15. So then we end up with y is equal to negative 3. So my y-intercept is 0, negative 3. Perfect. Now one thing I want to point out is notice how here the x-intercept was 5, which was in your problem, and negative 3, which was in your problem. It does not always happen like that. So don't think you can just look at your equation and see your intercepts right away. As you can see in example 3 here, neither of these answers were even in our problem. Okay, so make sure you don't try to do a shortcut because that does not work every time. Okay, now let's try example 5. So our steps when we want to graph our equation in standard form is we use our x and y intercepts. So let's go ahead and find our x and y intercepts. So x-intercept, cover up the y value. So I have 4x equals 24. Oops. Let's fix that. 4x equals 24. So that's going to give me an x value of 6. And then my y value is 0. Now let's find the y-intercept. We know the x value will be 0. Let's go ahead and use our cover-up method. And looks like our y value, when we divide by 8, will be 3. So step 2 for graphing is we plot our intercepts. The x-intercept was 6, 0. So I go 6, 0, put my dot there. Y-intercept was 0, 3, put my dot there. And then we just connect our dots. Connect your dots with a line. So this one's nice and easy because you just have to have your 2 dots on your line. You don't have to have 5 this time. Okay, let's try another one. Let's do our x and y intercepts again. So for my x-intercept, we're going to cover up the y value. So that one, don't even need to solve it. I get 4, 0 for my x-intercept. And then for my y-intercept, I know the first number will be 0. Cover up my x value. And now this one's kind of tricky. You see that negative with the 2? A lot of people forget about that negative with the 2 and think it's just 2y equals 4. So a lot of people will make the mistake of just putting 2 here for their y-intercept. But since this is a negative 2 times y, when you divide by negative 2, you actually get negative 2. Okay, so make sure you don't forget about that negative in front of your number with the y, if there is one. Okay, and then we graph it and connect our dots. So 4, 0, 0, negative 2, and connect them. Perfect.